So hello, for today our topic will be about superposition theorem. This is under circuit analysis of circuits one. This is circuits. So let's get started. Things that to consider when applying superposition theorem is superposition theorem is only applicable in bilateral networks. This only means that superposition theorem can be used with circuits having, for example, is a network consisting of only resistances and so on and so forth. That circuits that can be classified as bilateral networks. Number two is superposition theorem cannot be used in solving power calculations. So superposition theorem is very useful in solving complex circuit networks wherein we analyze because they have multiple voltage sources and current sources at which simple Ohm's law fails to satisfy or to solve these kind of circuits. Okay, so steps that we need to take. The first step is only one source acts at a time. We need to choose at which will be our reference sources, at which we will be having different directions of currents, at which on the last part will have a significance in solving the real-time currents or the actual currents that we are solving. Number two is ideal voltage sources corresponds to closed circuits. This is a type of connection that will be used when we are having independent sources that we actually neglect. And for ideal current sources, it corresponds to open circuit. And step number three is using Ohm's law, current division rule, etc. We need to solve currents using these uh, methods. Note that current directions are very important because they have a great impact or significance in solving the final or the real-time currents. Okay, so let's get started for our first example. For this example, we need to solve for I2. So when using superposition theorem, first we choose what is the first source that we will be considering. So for our first step, we will be considering only this voltage source, which is actually 15 volts. This is 15 volts right here. So 15 volts acts alone. So we need to redraw this circuit. So in redrawing, so when we redraw the circuit as 15 volts acts alone, we only consider the 15 volts. We need to replace the 4 amp source, this current source, with an open circuit, as of what I said earlier. So first and foremost, we need to uh, solve this total resistance at this point when we put a ohmmeter right here. So by doing so, what is RT? RT, our total is nothing but 12 ohms plus using product over the sums because this is parallel circuit, that is 10 multiplied by 40 over 10 plus 40, we get 20 ohms. Therefore, we can solve for I1 total, which is the total current. I1 is nothing but 15 volts divided by the total resistance, which is 20 ohms, which is equals to 0.75 amp. Okay, so when we already knew that the current right here is 0.75 amp, we can apply current division rule in order to solve for the current I2 right here. So using CDR, that is I2 is equals to the current entering 0.75 amps entering at this node multiplied by the opposite. What is the opposite resistance? That is 40 ohms over the sum. Over the sum, that is 10 plus 40, which we get, that is 0.6 amp. And we denote this as I prime, I2 prime, because I1, the total, the real time current the real time current I2 is different from the I2 prime that we solved by only considering one voltage source. Okay, so that's it for this part for 15 volts acts alone. So next step would be 4 amp voltage current source acts alone. So to do this, we need to redraw. We need to replace 15 volts with a closed circuit, 12 ohms, 10 ohms, 40 ohms, and 4 amps. Direction is very important. So you can see this is 12 ohms, 10 and 40. And by looking at this section, we can see that 12 ohms is in parallel with 10 ohms, as well as 10 ohms is in parallel with 40 ohms. Therefore, we can get our total prime in reference with the 4 amp current source as 1 over 12 plus 1 over 10 plus 1 over 40. We get 4.8 ohms. But at this case, we had already given a current source. Therefore, we can just simply apply CDR for us to able to get I2 double prime. Okay, because it is already in parallel. These three resistors in parallel, so we need to redraw. We need to combine 12 ohms and 40 ohms. This is 4 amps right there. This is 10 ohms. Here is the I2 double prime, and product over the sum to get 40 ohms, to get the combination of 40 in parallel with 12 ohms. That is 12 plus 40, which is equals to 120 over 13 ohms. Okay, so to solve for I2 double prime, that is nothing but opposite. What is the opposite resistance of 10 ohms? Which is 120 over 13. What is the current entering this node? That is nothing but 4 amps. We divide it by the total, which is 120 over 13 plus 10 ohms. We will be getting 1.92 amps. Okay, I2 double prime is equals to 1.92 amp. And as you can see, it also has a direction that is pointed towards uh, pointing downwards, meaning I2 prime, which we solved earlier, is also has the same direction with I2 double prime. Therefore, we will be having for the value of I2, which is equals to, we just simply add algebraically I2 double prime and I1 and I2 prime. However, this is actually a correction because the given was actually 4 amps volt current source is actually pointing upward. This is actually a mistake right here. It is pointing upwards. Okay, because if it was actually pointing downwards towards this node, we'll be having a negative value for I2 double prime. So by doing so, we will be having the following. As you can see, On our previous solution, this is I2 prime, this is I2 double prime. Therefore, the real-time value for I2, they both have the same current direction. Therefore, we must add them algebraically. I2 is nothing but I2 prime plus I2 double prime. Therefore, I2 is nothing but 0.6 amp plus this is 1.92 amp. Therefore, the final answer would be 2.52 amp. That is the final answer. Uh, and that's all for today. So I hope you learned something from this video. And this method is very useful in solving complex circuits. This is superposition theorem in circuit analysis. And that's all. Thank you for watching. Rufus boy, let me love boy, what you know. Rufus boy, let me know.